So this section is going to be about developing rules for mean and spread. So here we go. Suppose the city of Manhattan pays its pool employees the following monthly salaries. We want to find out what the mean and the standard deviation are for that. So there isn't anything special to that. We're just going to go into our calculator. I've already dropped everything I need to in L1, so we're going to go stats. We're going to go over to calculate. We're going to choose that one variable statistic. I want to do this on L1, so we hit second and L1. Whoop, that's not what I wanted to do. Clear that out, Shift and L1, there we go. And as we arrow down to calculate, it looks like we have a mean of 1391.67. And if I scroll, standard deviation is what we're after there. And again, remember, we're going to pick SX for this because most of the time we are dealing with a sample. So as we come back, we're going to fill this in. I'm going to grab, let's change my color. I got to turn my pen on. We'll go with hot pink. How about that? So we said it was $1,391.67. Okay, my standard deviation was $488.89. So again, if we, just to help refresh, if we wanted to try to interpret the standard deviation is my average distance each piece is from the middle. So the typical salary of a Manhattan pool employee varies $488 from the mean of 1,391. So just again, just a refresher on how to do that. All right, so now we're going to see what happens when we change numbers, okay? So the head lifeguard is proposing a $500 raise for all employees. What will happen to the mean and the standard deviation? So let's go back to our calculator and we can go in and figure that out. Stats and number 1. I'm going to go over here to column 2 and we're going to clear that out. Okay. Now in column 2, I want to give every employee in list 1 a $500 raise. So that's what I'll do. I'll put list 1 plus a $500 raise. Okay. And that's just an easier way to do that. And in the grand scheme of things, I would never, ever want you to even do this calculation. I want you to understand the theory behind it and just go ahead and give me the answer without having to do any calculations, okay? But now what we want to do is we're going to go stat, we're going to go over to calculate, we're going to choose option 1, except now we're going to do this on, actually I just need to get clear. Okay, we're going to do this on L2. So what happened? And we're going to assume then that my mean, it went up to 1891. However, if we look at the standard deviation, it is still at 488. So we saw that my mean went up to 1891.67, and my standard deviation remained at 488.89. So we can see that my mean went up by $500, and this stayed the same. Okay, and because if we think about this logically, I took $900 and I moved it up for $500 on the salary on the number line. Okay, and I did that for every piece, and every piece just moved up $500 on the number line. So we're here, 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 and here now instead. But in reality, we are the same distance from the middle. So therefore, that's why my standard deviation remained the same, is because everything is still the same distance apart. I haven't changed that. All I did was to change the spot on the number line where it was by giving everyone a $500 raise. Okay? All right, so scenario 2. Unfortunately, the pool is losing money to all the rainy days. Instead of giving raises, the city employee decided to cut everyone by $500. Now, I assume this means from where we were beforehand. So again, because now I know what happens, I'm going to go back to 1391, and now everyone loses $500. So now, without actually having to drop that in my calculator, we're going to say the new mean salary is going to be $891.67. And because all I did was move everything up and down, my standard deviation is going to remain the same at 488.89. Okay? So now here comes our general rule, okay? In general, what happens to the mean and standard deviation of a number is added or subtracted to each value, okay? So X bar is increased / decreased by the same number. Uh-oh. Standard deviation remains the same. Now, that question specifically asked for mean and standard deviation, so that's what we put in there. However, it actually affects more than that, okay? So when we talk about standard deviation here is a measure of spread, okay? So when we talk about this is going to be spread, this is going to be center, okay? Now, if I gave everything a $500 raise, or a decrease, my min, my max, my quartile 1, my quartile 3, my median, they are all going to increase, okay, that $500. Measures of spread are going to stay the same. So what other measures of spread do I have? We have the range, and we have the interquartile range, okay? So there's what we have to remember there. It's not just mean. The rule isn't just for mean and standard deviation. The general rule is going to affect all those, okay? All right, so now scenario 3. The head lifeguard points out that even though money was lost at admittance fees, the concession stand is making unexpected profits. So she gives everyone a 30% raise. What's going to happen to the mean and standard deviation? All right, so let's go back to the calculator. Again, this is going to be a rule that eventually we'll learn, okay? But we want to go ahead and we're going to work it out right now, okay? So I'm going to go into L3. We're going to clear that out, and we're going to make it everyone in L1 gets a 30% raise. So we're going to take L1, and we're going to take that times 1.3, okay? 100% of the salary plus 30% more. And now I have new values for L3. So let's come back to stat. We're going to go over to calculate. We're going to choose option number 1. We're going to clear that out. And now we're going to drop an L3 in there. And we're going to calculate what that is. All right, so we have to remember 1809.17 and 635. Luckily, I have that written down because there'd be no way I would remember that. We're going to shift colors to, I don't know, I'm on pink now. We'll do baby poop brown here. All right, we said that was 1809.17 and 635.56. Okay, now the thing is, though, I had to figure out what was that change. What happened? Okay, how did I go from, if we looked at my, remember the mean was 1,391. So now we need to go, what was that? So what was that increase? Okay, so if we look at, we have 1809.17. If we subtract off the original, which was 1391.67, and then we divide by the original of 1391, that's going to give me 30%. So what happened is my mean increased by 30%. Now I can see up here that my standard deviation was 488. That had never changed all along. But now it's at 635. So my average distance from the middle has changed, and now it's 635. And to cut to the chase a little bit, we could go ahead and figure out that percent change, but we're not. Okay, this also equaled my standard deviation times that 30%. Okay, so it increased by the same factor. Okay, so let's and there's not enough places here, but let's say this is here's my old data where it was. Okay, so for example, let's say this person right here made $1,000, and this person out here made $5,000, and everyone got a 30% raise. Okay, so what's 30% of $1,000? That'd be $300. So this person, I don't know if we can see yellow or not. Yeah, maybe we can. This person's going to go up to $1,300. I'm going to guess you can't see that. So we're going to go orange. Okay? This person is now making $1,300. Now let's come up here to the $5,000 person. They're going to get a 30% raise. So now this person is making 30% is going to be $1,500. Now they're making $6,500. So if we look here, this person got a raise of $300. This person up here got a raise of $1,500. So we can see that the distance, this point, moved from here over to here. It moved $300. This point, however, moved from here clear up to here because it moved by a larger amount, $1,500. So when I multiply by a scale factor, my points are getting further apart because some are getting a large raise and some are getting a small raise. Okay? And again, there's very little room in there to show that. So anyway, we'll just leave it at that. This is awful scribbly, but we haven't done scenario 4. At the end of the summer, the city of Manhattan decides to give everyone a $500 bonus plan plus an incentive of 10% of the employee's salary. What happens to the mean and standard deviation? Okay. Actually, let's jump down here, and that's a totally different question. Okay. So let's jump down here and fill out the in general question. Okay. And this is pretty easy. All summary statistics affected by multiplication. So it doesn't matter what we're doing, it's going to be 30% larger or 10% smaller. And if I could spell multiplication, we'd all be better off. Okay, that was simple. So what we have to remember in doing that, in scenario 4 here, okay? In scenario 4, Manhattan wants to give everyone a $500 holiday bonus plan. So we're going to give everyone a $500 raise. However, we're also going to give a 10% bonus to the 10% of the employee's salary. Okay? What happens to that? So we're going to take this to figure out this new mean. Unfortunately, I have very little left here to, very little room here to write that, but we'll try to squeeze it in here. Okay? My mean was 1391.67. To that, everyone got a $500 raise. And then we got a 10% bonus, so we have to figure out what is 10% of 1391.67. And if we add all of that together, we're going to get 2,030.84. Okay. Now, I'm going to go ahead and grab my eraser tool and get rid of some of this stuff. I'm sorry. If you don't have space to write it, you're going to just have to find, I don't know what that does. That's crazy. Okay. So we're going to start out with my mean. My standard deviation was 488.89 plus. Now, the thing I have to remember is when I added the $500, measures of spread are not affected by an addition, okay? Because everything just moves up in the number line. So I'm not going to add $500 to that. However, I am going to add a 10% rate, 10%. So we're going to take 10% of 488.89. And that's what my new standard deviation will be, 537.78. Okay? So that's what we have to remember. Again, this is just general rules for how a set of data reacts to being increased by a constant or being increased by a scale factor. And that's what we're going to do there. All right, I can shut this video down and we'll say